Hello everyone, welcome back to the channel. In today's lecture, we will discuss an important concept in microcontrollers. In lecture 4, Memory Organization of 8051 Microcontroller. In this session, we will understand how memory is structured and managed inside the 8051 microcontroller. We will cover some key topics. First of all, the internal and external memory structure, which explains how the microcontroller stores and accesses data and program instructions. Next, we will study data memory, also known as RAM, random access memory, and program memory, which is ROM, read-only memory, along with special function registers SFRs that control different operations. We will also explore the concepts of bit addressable and byte addressable memory, which make the 8051 very efficient for handling data. And finally, we will understand the stack, which is used for temporary storage during function calls and program execution. By the end of this lecture, you will have a clear understanding of how memory works in the 8051 microcontroller and how it supports efficient program execution. So let's get started. Now we will see here the recap on the pin diagram of 8051 microcontroller. Right? First of all, we have studied the pin diagram of 8051 microcontroller, 40 pin configuration of the 8051 microcontroller, input-output ports from port P0 to port P3, and power supply, oscillator pins and control pins. These all things we have discussed in the previous lecture, right? Now we come on the learning outcomes. First of all, after this today's lecture, we will learn identify the different memory types used in 8051, right? RAM, ROM, SFRs. Okay, remember these things. Next thing, discuss the difference between internal and external memory organization. Okay, and also analyze how bit and byte addressing is managed in 8051 microcontroller. Okay. Memory organization of 8051 microcontroller. First of all, the 8051 microcontroller memory supports hardware architecture. Okay. Next thing, hardware architecture. In this type of architecture, both the memories, address and data are treated as separate units. That is the benefit of this structure, right? Next thing, on-chip memory. 128 byte of RAM, that is the data memory. 4K byte of ROM, ROM, read only memory, that is also called the program memory. Okay. External memory we can also included in the 8051 microcontroller. First of all, we can include 64K byte of RAM, that is data memory, 64K byte of ROM, that is program memory. Understood? We can also include these things. These on-chip memory already included with the 8051 microcontroller. If we require the more memories, we can include these external memories with the 8051 microcontroller. Right? The data memory, just more explanation of this. Bank registers, right? This is related to the bank registers. Working, that is called the working register, right? Bit byte addressable location, general purpose RAM area. Okay. We will also explain in the detail in future slides. Basically, this RAM portion will come in the 8051 microcontroller. Right? Now, internal data memory, that is RAM, organization of 8051. Right? That is the very important things of the RAM 8051 microcontroller. So how to divide the RAM location? So step by step we will see. You can easily understand of this. First of all, you see here, right? So we can start from here, from down to up. Okay? To start from here, 00 location, the register is available here or not, right? 01 location, the register already here R1, right? This is the space basically, you know. 02 R2, these things are here. This is the space of the 8051 microcontroller RAM, right? We can see here the another RAM memory also given, this one, right? 22 2F. Okay, this is the bit byte addressable location. These also given location for RAM, right? Next thing, general purpose RAM area. This is basically, this is completely called the RAM, right? These are for these areas for the register purpose. Okay, this area for the bit byte addressable location. This area for general purpose RAM area. Location already given here, also given here, and also given here. 30H to 7FH. These are the locations of the 8051 microcontroller RAM. So now we will see in the detail how to divide these things. So first of all, we can see here, this is the bank 0. This area is called the bank 0. We can say the register bank 0, right? The location of this bank is 00H207. Okay, this is the hexadecimal values. Now we can divide this bank 1. Bank 1 start from 08 to 07. These areas, only 8 locations are given in bank 1. And also here the 8 locations are given for bank 0. Right? Next bank 2, this is also has the 8 locations, right? In one location we can store and we can process 8 bits, okay? The registers already given here are not to R7, right? And next thing, bank 3, this is also has the 8 locations, right? In a location we can store data, 8 bit data for the processing purpose. Okay, remember these things. Default bank, that is called the bank 0. Suppose any question arises about this, what is the default bank? You remember the default bank is bank 0, right? Default stack, this is the bank 1, that is called the default stack. Okay, default bank 0, default stack bank 1. Okay, so now we can see here, so in default condition, the location, starting location of the stack pointer is 07, right here at this location. But we want to add something, this cursor or stack pointer come here, we can put any data, right, in this thing. Now you can see here, this is the 002 07, right? This one 00H, 01H, 02H, 03. You can see here, right? 00207. This is the basically 8 digit, right? 8 locations, right? Given here. Right? In the same way, we can represent this here 08 to 0F, 10 to 17, 18 to 1F, 20 to 27. In this way, we can represent the locations, right? In the okay, special function registers, that is SFRs, and their address, right? So these things we have divided into 3 parts: name of the register, function of the register, internal RAM address, right, in the hexadecimal form. First of all, we can see here the A register, right? The function of this register is accumulator. Okay, this is the beneficial for store the result of arithmetic and logical operations, right? The location of this register is E0H. B register, that is the for arithmetic also, that is RAM location for this register is F0H. For DPH register, that register, the function of this register is addressing external memory. The address, the location of this register is 83H. In the same way, DPL addressing external memory, that is the 82H. Okay, i.e. the register name. The function of this register is interrupt enable control. The location of this register is A8H. Next register is IP register. The function of this register is interrupt priority. The location of this register is B8H. Okay. Next one, P0 register, that is the P0 latch. The location of this register is 80H. Understood? P1, that is the port 1 latch, that is 90H location address, right? P1 register, that is the port 1 latch, the 90H, that is the location for this, right? Next register is P2 register, that is the function of this register is P2 latch. Okay, the location of this register is A0H. Next register is P3 register, that is the port 3 latch. The location of this register is B0H. Okay. Next register is PCON, that is the power control, right? The location of this register is 87H, right? PSW register, that is the program status word. The location of this register is D0H. Okay. Next register is SCON, that is the function of this register is serial port control. The location of this register is 98H. Remember. Next register is SBUF register. That is the function of this register is serial port data buffer. Okay. The location of this register is 99H. Understood? Next register is SP register. That is the stack pointer. The location of this register is 81H. Remember? Next register is TMOD register, that is the timer counter mode control. The location of this register is 89H. Okay. TCON register, that is the timer counter control register. The location of this register is 88H. TL0, timer 0 low white, that is the 8AH location of this register. TH0, that is the timer 0 high byte, that is the 8CH location of this register, right? Next register is TL1, that is the timer 1 low byte. The location of this register is 8BH. Next register is TH1. The function of this register is timer 1 high byte. The location of this register is 8DH. Okay. So remember, if we want to use any registers, right? So the location already given, right, in the RAM. Understood? Next thing. Now we will see here program memory of 8051 microcontroller, right? First of all, we will see here the EA pins is connected with the ground, right? This is for the purpose of internal program memory, that is the range of this memory is 64 KB, right? So the addressing of this memory is 0000H to FFFFH. Okay. In the same thing we can use here, that is the 5 volt supply put here in the EA. EA is nothing but external access. Okay. The range of this memory is 4K. The starting address 00H to 0FFFH. Okay. And this is the thing connected with the external, right? This one. External program memory, the range of this 64K byte. Okay. The location of this 1000H to FFFFH. Okay. So now we can see the internal versus external program memory in 8051 microcontroller, right? Now let's understand how program memory is organized in the 8051 microcontroller. In this diagram we are comparing two important cases based on the EA pins. EA pins, that is the external access pin, which stands for external access, right? First, look at the left side. Here the EA pin is connected to ground, 0 volt. This means the microcontroller will completely use external program memory, right? In this case, the 8051 does not use its internal ROM, okay? And all the program instructions are fetched from external memory, which can go up to 64 KB, starting from address 0000H to FFFFH. Okay. Now look at the right side. Here the EA pin is connected to VCC, right? That is the 5 volt supply. This enables the use of internal program memory. The 8051 has 4 KB of internal ROM, which occupies address from 0000H to 0FFFH. After that, if more memory is required, the microcontroller automatically accesses external program memory. That is starting from address 1000H up to FFFFH. Okay. So the key idea for this, EA equal to 0, that means only external memory is used. Okay. EA equal to 1, that is internal memory plus external memory is used. Remember, right? This concept is very important because it determines where your program is stored and executed, right? Now, we will see here external data memory of 8051 microcontroller. This is the microcontroller 8051, right? Now we want to connect this 0 voltage to EA pins. EA pin, that is the external access pins. That is the thing we want to use as a external data memory, right? The addressing of this memory 0000H to FFFFH, right? Now we come on the summary of this today's lecture. In this session, we explored the memory organization of the 8051 microcontroller. That is covered key components of this internal memory and SFRs, special function registers, right? External program memory, external data memory, okay? In the next class, we will see in the detail of this thing. We will explore the addressing modes of 8051 microcontroller and how they enable flexible data accesses and instruction execution. Right? Remember this thing we will discuss in the next lecture. Right? Lecture number 5. Now we come on sample questions. These are the some questions scenario based given in this slide. Right, first question, you are developing a program on the 8051 microcontroller that includes nested function calls and interrupt service routines. Okay, during execution, you observe that the system behaves unpredictably and data seems to be lost or overwrite. Right? Question. How would you configure the 8051 to use external program memory and which control pins and ports are involved in interfacing an 8 KB external ROM? Right? So you can solve this question. That is the important thing related to this topic. Right? Next thing, the scenario is available. You are developing an embedded application, right? Using the 8051 microcontroller, right? That requires 8 KB of program memory for storing code and data tables, right? The internal ROM of the 8051 is only 4 KB. Understood? The question is, how would you configure the 8051 to use external program memory and which control pins and ports are involved in interfacing an 8 KB external ROM? Okay? Okay. Okay. Memory may be invisible, but In a microcontroller 8051, it holds the blueprint of every intelligent action. Thank you very much for listening me.